what kind of opportunities are we talking about? I think not all of you might be super into AI and machine learning, probably more into security, but I guess you all have seen the news recently about ChatGPT and all kinds of privacy concerns, issues. Italy was very prominent in the news, banning ChatGPT initially. Big companies like Google, Apple started to lock down on how employees can use generative AI like ChatGPT, but also GitHub Autopilot, anything that might leak potential sensitive data. That could be anything of like IP or privacy of the company's internal data. And there were even some news about Samsung actually, leaking some trade secrets. Whether this is true or not, I think that's kind of concerning. So the problem and the opportunities we see for a solution here are going to the direction of institutions, companies, governments locking down on generative AI and basically blocking the use of these tools, and thereby also locking their employees, their citizens of generating value of this technology. Not sure, who of you was here at the last meetup? Maybe raise your hands. Okay, so not everybody. Okay, last time Felix gave an introduction into confidential computing and what we do at Edgeless Systems. I'll try to keep it very brief and just explain some of the concepts that are also relevant today. I hope that everybody can follow, otherwise please feel free to ask any questions just during the presentation. So the very brief summary of confidential computing is that we now have new hardware that allows us to keep data encrypted in memory while it's in use, and also do some form of attestation, verify what's happening inside this encrypted environment so that we can isolate ourselves from the infrastructure, from any other tenant, any other entity inside this potential hostile environment, such as the cloud. This is the cloud native meetup. So the question is, how do we apply this to cloud native environments? Very briefly speaking, Felix presented 3 ways of doing that. One would be to consider our cloud native environment. For example, our Kubernetes cluster is one concise application that you can isolate as a whole, as a private space in the public cloud. One was that you take individual containers, individual workloads, and isolated them. And then you need to take care of orchestrating them without trusting the orchestrator, such as Kubernetes. And the last one was maybe a bit more specific, technology specific, was for Intel SGX, probably the first iteration of confidential computing, where we can isolate an individual process inside a container. That's very similar to the confidential containers, just requires some more different tooling and how we can apply that to our workloads. But generally, that was what Felix showed last time. This time, we want to do the same thing, but we want to focus on a specific type of application. Generative AI, machine learning. So I guess the first question would be, what would be a ChatGPT kind of application stack in our cloud native environment? So what does cloud native AI even mean? And the good thing about these tools is you can just ask them. So if we ask ChatGPT, what is generative AI? I guess it's what most people would expect. It's basically using our cloud native deployment stack for building applications, having the benefits of flexibility, scaling, any kind of the modularized environment that the cloud native environment gives us. And the question is that a good stack? Does it make sense to deploy ChatGPT on Kubernetes in the first place? And I would say for AI workloads, it's not as defined yet as it's with other applications. I think it's a more diverse stack. But big players such as OpenAI are very openly about using cloud native environments. So OpenAI, I think since a couple of years, is always presenting how they make use of Kubernetes, for example, for leveraging a big scale environment. So you can say it's not as defined yet as it's with other applications, but generally we see a path where also AI and machine learning applications make use of the cloud native stack. So what would that look like if we want to deploy a ChatGPT on Kubernetes? Of course, you need some hardware, usually some very recent GPUs to be able to have the computing power to do so. Then we usually have something like Kubernetes. And on top, we might want to do some additional orchestration. I say we don't necessarily need to, but we might want to use some additional orchestration that takes care of, for example, building a event-driven inference pipeline where I want to distribute my requests among different workers, different GPUs. I want to represent my machine learning life cycle in a way where I have some insights, some observability. I can deploy some kind of like dashboard or iterate over a model, orchestrate my training pipeline, stuff like that. And there's some orchestration that's specific for my machine learning operations that I want to deploy on top of the general orchestration. And then on top of that, I usually have some form of model runtime or framework that I use to develop and actually build my models, process the data. And the famous one, I guess, are TensorFlow and PyTorch. And I said we might want to use an orchestration platform because we can use those even without the actual orchestration. PyTorch has its own serving, similar to TensorFlow, has its own serving modules. We can have an inference server that builds an inference service without even having any kind of this middle layer here. And of course, there is not only the open source world, the Kubernetes cloud native world, there's also from all the big cloud providers, they have some form of platform that takes care of maybe anything in that stack, right? So that goes from the orchestration part through the MLOps part, through the lifecycle part. But this is all more or less proprietary, so focus more on the left-hand side for this discussion. So this would be our stack. This would be roughly how most people deploy AI workloads on Kubernetes. Maybe they have their own orchestration. Maybe they don't use Kubernetes, just use containerized workloads directly with Docker Swarm or something. But generally, that could be the stack. So repeating the problem, now we have this stack. We want to offer a confidential ChatGPT. What would be the solution to isolate the data and me as a service provider, or the data and the infrastructure? I generally see two solutions. One is we bring our stack to the customer that has the data and protect our model, our inference stack, or we are able to isolate ourselves from the data we consume as a service provider. Bringing the model to the customer is, I'd say, maybe a bit more niche. I'm not going to focus on this for this talk, but technically I could use confidential computing here to encrypt my model at runtime in the customer environment. Of course, then they have very high requirements in terms of what the customer environment would need to look like from a hardware perspective, having the confidential computing hardware, having the latest GPUs. And similar to most cases, if I need to ship my model to, or my workloads to the customer, usually all of the operations, day two operations are a bit more, require a bit more effort instead of being a SaaS provider and having everything under my control. Which brings us to the second case where I'm the SaaS provider, I host everything myself, and I need to exclude myself and the infrastructure from the data, so I don't run into any privacy issues here or any concerns about what happens to the data. And then I need to make this verifiable, making this meaningful verifiable, right? We'll see in a second what that means. So confidential GPUs is the fundamental building block. That's the news, I guess. Felix presented this also last time, but this is the new things in terms of confidential computing hardware that we have now, that not only the CPU is able to protect data at runtime, also the GPU can do that. And it has similar properties. It has a form of attestation, has a form of isolating my data from any unwanted access. And roughly, the way a confidential GPU is seen in terms of our confidential context is a trusted device, a I/O device that our confidential context wants to communicate with, and that we need to attest and establish secure channels with. And there's a protocol being established called the SPDM, Secure Protocol and Data Model, that defines a standard how this AI device communication works. But briefly speaking, we need some kind of driver that speaks this protocol with our GPU, establishes a secure channel, that does some form of authentication or attestation, and then data can flow between those two contexts, and we can see them as, again, one confidential environment, and nothing outside of this context has access to the data. What this currently means with the current generation of confidential VMs and confidential GPUs, such as the NVIDIA H100, is that we use some form of bounce buffers. So we have our encrypted memory for the confidential VM. There's no direct memory access possible for the GPU, so we define a shared memory. We encrypt the data written into that shared memory via a shared key, and then the GPU has access to that shared memory that's unencrypted, loads it into its own memory and processes from there. With the H100, this memory of the GPU, in fact, is not encrypted, but the NVIDIA says it's unaccessible by anything, and pretty much has the same properties as the encrypted memory of a CPU in terms of what it would cost to actually access this memory and leak any data. So that's the rough model, and as you can guess, maybe this bounce buffer model means that we always have this data transfer. There's a shared channel between the two that uses encryption, decryption, and we always have to go through that bounce buffer. And that causes, of course, some overhead that we can see in performance. But interestingly, if we are bound by I/O, as you can see on the right-hand side, which is a convolutional network, where processing of the actual pass through that model is relatively fast, and we are more bound on the I/O side, we can see a performance decrease, in this case, roughly 50%. But the good thing for us is, since we are focused on the latest generation of generative AI, which is mostly very large transformer models, where we are bound more by processing and less by this I/O transferring and how many requests we can do in a second, we see almost no performance degradation. So in that regard, we're lucky here if we want to build something like ChatGPT. Nevertheless, it would be interesting, what can we do about this performance issue? And there's something on the horizon that's roughly being under this trusted devices envelope, where essentially the confidential VMs, the CPU technology is advancing and is providing a way for verified, trusted devices to do direct memory access. So instead of going through a bounce buffer, we use SPDM protocol to give a authenticated, attested device the option to directly access the encrypted memory of our confidential VM. And then we lose this performance overhead. So that's the rough idea of how confidential GPUs work in terms of memory encryption or memory transferring. Operational-wise, we can use them as any other GPU. We can chain them together. So you can have multiple GPUs connected to the same confidential VM, or we can have we can use them as a non-confidential VM. So nothing really changes in that regard. So we're good on that. The more interesting question is now, how does the attestation work? So I have a confidential VM, I have attested that VM. How do I know that also all of the devices, like a GPU, was attested correctly, and it's exactly the NVIDIA firmware on there that I expected to be there, and I don't know, the cloud provider didn't use a breached firmware or something. And the rough idea is that we include the attestation of that GPU into the attestation of our confidential VM. Again, some callback on Felix's presentation on how we attest a confidential VM. Just real short recap, if you're familiar with TPMs and measured boot, this might sound familiar. Essentially, we create a chain of measurements that reflect the chain of our boot by having one component always measuring the next one before transferring execution, which then results in basically a table of boot component to hash that we can include into our attestation report. So if we test a confidential VM, we obtain an attestation report, the CPU adds some metadata, and then the CPU, or we attach this chain of measurements to that attestation statement. Yeah. So there's a clear link to these measurements. And now the idea is, can we somehow add the attestation of our GPU to this process? And roughly the idea is that we also the kernel, when it's booting up the device driver, also does the attestation of the GPU via the SPDM protocol, and then we basically extend these measurements with the attestation of the GPU. And then we have one concise statement from the CPU about potentially all of the trusted devices currently about the GPU. In the future, this might be, I don't know, multiple GPUs or other accelerators that have the confidential computing properties. So this is roughly how we can do attestation. So we went very deep into the tech now. Going back into the cloud native stack, what we have now is we have a confidential VM plus a GPU that's attested, and that we now somehow have to apply to this stack. Again, keep in mind our goal is we want to deploy, let's say, a ChatGPT with that stack on top of a confidential GPU, and excluding the infrastructure, whoever is the infrastructure, and us as the service provider of this application. And if we remember those three pillars of how confidential cloud native computing can look like, with Constellation, or the concept of a confidential cluster, we would roughly include those confidential GPUs into our worker nodes. So every worker node could have potentially multiple GPUs connected to it. We attest them, and then they are part of our big environment. And then from inside, we can just deploy the stack. So nothing really changes from that perspective. Of course, if we are the provider, the SaaS provider, this would not exclude us from the data. So this would give us the infrastructure isolation, but there's no separation between us and, let's say, PyTorch processing the input request. One step closer is when we use the concept of confidential containers, where we can cut off at the layer of the container. So that means the platform, Kubernetes, and what other orchestrator we might deploy in is not part of this context, and we can actually isolate the container itself and anything and its use of the confidential GPU. What we need to do, of course, is in the context of confidential containers, we need to do all of the stuff I've shown for how we attach a confidential GPU to a confidential VM. We have to do this in the micro VM of the confidential containers. And there's ongoing work. I'm not going to explain this, but there's a lot of stuff going on how people are arguing and discussing how this can be included into the micro VM confidential container context. But it works roughly the same as I've shown in the slides before. And now the big question is, does this already give us the solution we are aiming for? If we just take our ChatGPT, we package all our containers inside confidential, all our containers inside confidential containers, and we're done. And I think the main observation here is that this is just a starting point, right? There's not really, we still have to think about all of the orchestrational part. How can I attest from the outside? If I use ChatGPT, how do I know this is running inside confidential containers? How do I know what they do inside there, right? So what does the inference code, for example, written in PyTorch, what does it do with my data? Does it log my query to some database or some logging service? It can be taken from there. Is my data processed by its own, or is somebody else's query batched together? All of these questions need to be answered. So I think it's a starting point, isolating just the container, but it's definitely not an entire solution for confidential AI. And I think this is where things get interesting, and now where the new opportunities lie: building applications, building services for these problems. Interesting, because Sven is here from Bosch. Back in 2020, I think we were very visionary about this problem, where we built a confidential AI pipeline, also for inference, back then on CPUs, because we didn't have any GPUs, where we actually built a pipeline for an inference, and also, yeah, it was maybe inference and training pipeline based on K-serve. That was maybe one of the first sketches for this problem. So I can just recommend watching the talk. It's, I think, on YouTube from Microsoft Build in 2022. We were dealing with exactly the problem: how can you process privacy-relevant information that might be captured by a car video or car fleet's video cameras for training a driver assistance system. Yeah. So this is, I guess, a lot of new space to explore and very interesting problems. Now that we have the confidential GPUs and we can extend our model from just a VM, just a CPU, to additional devices, additional accelerators. Yeah, so takeaways. I guess I hope the problem about why privacy concerns are particularly relevant for AI and for generative AI came across, and that confidential computing can provide an interesting technical solution for this problem. What do we need? Confidential GPUs, potentially anything that isolates individual containers, and a lot of new solutions for how we can make this make the attestation meaningful. How can we provide an orchestration and anything along the lines of machine learning operations. So yeah, new opportunities and hopefully some interesting solutions in the future. That's it. Thank you, guys.